Hello, this is Jude. This is target 4B. I'm going to demonstrate how I can translate between the algebraic expressions, truth tables, and logic circuits. For the first question, I just need to write the unsimplified Boolean equation and make the truth table. I already prepared the truth table with just the A, B, C, which are the inputs right here in our logism exercise or circuit. So what I like to do is first look at the gates and see what gates we have so I can see what's being multiplied and what's being added and knotted and stuff like that. So off the bat, I can see I have right here, I have the AND gate and an OR gate and a NOT gate right here. So I'm going to start by writing the A. Well, actually, this is going to equal P since our output is P. So I'm going to say P is equal to A. And the first thing that we see right here is that A is being multiplied by prime B. So I'm going to say A times B prime. And then right here, B prime is also being added with the C. So I'm going to say B prime plus C. And then as you can see right here, we have a NOT gate, which means we're going to have to put this in parentheses and NOT it. And both of these expressions are being ANDed by this AND gate, so they're ANDed right there in the middle. And then at the end, we get an A going all from here down to this AND gate and being multiplied by all of this expression that we have already. So we're going to put this whole thing in parentheses and end it with A. And that's my simplified Boolean equation for this. Now, looking at this, I want to make a truth table that can tell me how this is going to work. So right off the bat, I see that I have A times B right here, A times B prime times plus C, and then it's also knotted out up here. So I'm going to put all these intermediate terms, is what we call them, in our truth table. And I'm going to start with the first thing that kind of happened. The first thing that kind of happened was we started with knotting the B and then ending A and B. So I'm going to say B prime right here, and then them being ended together, which is right there, the step. And then I'm also going to do that second part, which is the B prime plus C. So I'm going to write it this way, C plus B prime. And then I can write that whole thing over here. I don't know if it's going to fit right here. A times B prime, B prime plus C. And then this one is going to be the same thing, A times B prime plus C, and we're gonna have to add the A at the end. And that's actually what P is equal to. So technically I don't need to have this part, but I'm still going to put it either way. So let's go ahead and fill these out. So what is B prime going to be? I can tell what B prime is going to be from looking at the input right here. So we have 0 prime is 1, 0 prime is 1, and then 0 0 1 1 0 0. That's all for the B prime one. And then for A times B prime, so we're going to multiply the A variable by B prime, which is this variable and or number. And A, 0 times 1 is 0, 0 times 1 is 0, and then 0. Anything times 0 is 1, so I can just keep writing with zeros until I see a 1 times 1, which is right here, and then right here. Then here we go back to 0, and then we go back to 0 again, because 1 times 0 is 0. So let's do C plus B prime, which is C plus B prime. So our C digit plus B prime. Oops. There we go. So C plus B prime. Now this one does not work like timing. Stuff would not cancel out as much here, so 0 plus 1 is 1, 1 plus 1 is 1 in here in binary, or in logic circuits we can't write 2. Obviously I can't write a 1 0 in there, so I have to, it just stays 1. And then let's do this one, 0 1 1 1 0 1. Now let's do the a times b prime, and then b prime plus c, and then both of these timed together. So I'm basically going to multiply this together, which we're about to do that. Cool. So 0 times 1 is 0 0 0 0 1 1 0 0. Then we're gonna do the same thing here, but we're gonna multiply these numbers by a. Let's do that. 0 times 0 0 0 0 0, and then we can have a 1 here and a 1 here, then a 0 and a 0. And that's the same thing for p basically. I just accidentally added that one extra row in my truth table, but that's it. That's all it is. That's the truth table and the expression. And now we can move on to the second problem. So I'm going to draw the logic circuit diagram for this one. What I like to do is identify what gates I'm going to use. So off the bat I can see there's a NOT gate, so I'm gonna say for NOT gates I'm going to have one gate, and then there's 1 right here, so 1 plus 1. And then for the AND gates I'm going to have 1 right here, and for the NOT OR gates we're gonna have 1 and 2. Alright, let's start with our inputs. So X, Y, and Z. So X is being ANDed by our Y prime. So we're gonna NOT Y prime. We're gonna NOT it, so we can have Y prime, and then we're gonna AND them together. And then after that, we're gonna get that value and OR it with our next equation that we still haven't done yet. So Z plus Y prime. We already have Y prime over here, so I can just take that Y prime, put the OR gate, so I can add Z and Y prime. And when I add Z plus Y prime, there's a NOT gate right here, so I still have to add that NOT gate, so I can NOT them. Then once I have that, I can take that value, add it here, and then we get F, which is our output. That's it. And that's how to draw the logic circuit diagram, where this is basically Y prime, and then right here it becomes Y prime X, and then right here we have Y prime again, and then Z. Then right here becomes Z plus Y prime, and then right here becomes Z plus Y prime, and then primed on the outside. And then we add both of them, we get Y prime X plus Z plus